So then we say today we are looking at the third application of matrices. Applications of matrices. Applications of matrices. So this one, we are going to look at something called input output analysis. Input output analysis. That's what we are going to look at. And when you talk about input output analysis, it is simply a study of how sectors in an economy depend on each other. It is about the interdependence, and the interdependence is specifically how a center obtains the input, as in from who and in what quantities, and how the output from a sector is used, again as in by who and in what quantities. So in doing that, we normally have we prepare a table, and the table, if it is expressed in whole numbers, it is called transactions matrix, and if it is in ratios, it is called technological coefficients matrix. So I would want to handle that using a question. I want us to handle that using a question in a very simple way. There is this question of November 2019. November 2019 is on page 12. November 2019. November 2019. Question number 1C. Question number 1C. You have seen it, eh? Okay, so the question says, a small economy has two sectors, X1 and X2, producing a single product for their internal and external demand in units, are summarized in the following transaction matrix. So we have that. The projected consumer demand changes to 400 units and 800 units for sector X1 and X2 respectively. You are required to get the gross output for each sector in order to meet the new demand. In order to meet the new demand. Now, the first thing is to get what we call transactions table. Transactions table. So current transactions table. So in the current transactions table, we have the producer here. We have the producer. Producer is X1, and then there is X2. Then we have the user. The user, we have X1, then X2. Then we have what we call final demand. Final demand. And then we have what we call total output. Total output. Total output. So these one at times or quite often we present them using matrices. We present them using matrices. Remember, we are in the topic of matrices. The topic of matrices. of matrices. Topic of matrices. So as we have said, we are looking at how sectors interact. So we have a sector that is called the producer, and we have a sector that is called the user. So according to this one, X1, this is 500. X1, X2, we have 800. Then this is 600. Then this is 1400. Now we say plus the final demand. The final demand is the one that you can see there in the question being explained as the projected consumer demand. Oh, before we go to the projected, we are dealing with the current. The current is 200 here and 400. That way. So when you add like this, 500 plus 800 plus 200, that is 1500. Okay. Then 600 plus 1400 plus 400 is 2400. Now, in terms of matrices, this one is called matrix A. This one is called matrix Y. And this one is called matrix X. In terms of matrices, that is how we label them. This is how we label them. So, let me explain a bit. First of all, you can see we have something we are calling final demand. Now, final demand is the demand used by the last customer. Then we have the intermediate. This one is called intermediate demand. It is the demand that is used by the other sectors and the sector itself. So the argument goes like this. This 500 is the output from sector 1 that goes in as input to sector 1 so that sector 1 can produce a total of 1500. This one is the output from sector 1 that goes to sector 2 so that sector 2 can be able to produce 2400. This one is the output from sector 2 that goes to sector 1 so that sector 1 can make 1500. This one is the output from sector 2 that goes to sector 2 so that sector 2 can make 2400. So that tells you when we are using we have the whole numbers, you can see now A plus Y equals to X. You can add that. A plus Y equals to X. So if you are told to get technological coefficients matrix A in terms of ratios, this is how you get it. This is how you will get it in terms of ratios. L will be X minus Y. Yes. Yeah, in the reverse. So I've said this is everything that is required for this one. So we want now to express it per unit. So per unit, then you say it is 500. You divide by 1500. Then this one, it is 600. You divide by 1500. So if we take the calc, it will be 500 divided by 1500. That gives us 0.33. Then 600 divided by 1500 is 0.40. Okay. Yes. Then this other one, it will be 800. You divide by 2400. Then 1400. You divide by 2400. So 800 divided by 2400 is again 0.33. And 1400 divided by 2400 is 0.58. So that is called technological coefficient matrix. Technological coefficient matrix. It is still this matrix A, but the difference is that this one is expressed as whole numbers. And this one, or for the totals, yeah. But this one is expressed as ratios for 1 unit. So this is the output from X1 that is required to make 1 unit of output from X1. Yes. So now here you'll be saying in terms of 1 unit, 1 unit. You can see that, eh? Yes. Okay. So now, from there, maybe something else that you could modify here or you could add is that a row shows use of output or uses of output. When you're dealing with this matrix, these rows are showing us the uses of output. Then a column shows sources of inputs. Sources of inputs. The other thing is when A is in ratios, X is given as I minus A inverse multiplied by Y. If you are in ratios, X will be given as I minus A inverse multiplied by Y. So that tells you we have 2 formulas of getting X. The first one is what we had. I is 1. Yes, it's called the identity matrix. The whole number. Yeah, it's a whole number. Yes, but when we are in matrices, we don't use 1. Yes. We use the identity matrix to represent 1. Good. So having said that, we can now come here and say I minus A will be equal to, now an identity matrix is a matrix whose major diagonal elements are 1 and the other elements are zeros. So this one will be 1, 0, 0, 1. So you can see the major diagonal, it is 1, the others are zeros. Then you minus our matrix A, this one, which is 0.33, 0.40, then 0.33 and 0.58. You had checked operations of matrices, eh?
Yeah.
So therefore the answer here will be 1 minus 0.33, that would be 0.67. Then 0 minus 0.33, it would be minus 0.33. Then 0 minus this is minus 0.40. And 1 minus this is 0.42. So that is the matrix. Now, when you are told to look for inverse of a matrix, because this is the inverse, they are basically 2 steps. The first step, you get the determinant. The determinant. So the determinant, we know that determinant is normally written like this. The name of the matrix within 2 strokes. That's how you write the determinant. So, determinant we know is the major diagonal product minus the minor diagonal. So that would be 0.67 multiplied by 0.42. You minus, minus this other one, minus 0.4 times minus 0.33. So this one, if you take a calc, you will find 0.67 times 0.42 minus minus 0.4 times minus 0.33. 0.1494. 0.1494. That's the determinant. Then there is something else we call new matrix. New matrix. So new matrix is, you get it by interchanging positions of the major diagonal. The major diagonal, you change positions so that we have 0.42 here and we have 0.67. Then the minor diagonal, you change signs. Yes, you change sign. Good. So 0.40 and 0.33. That's called the new matrix. Then the inverse. That is I minus A inverse. It is given as 1 out of the determinant, 0.1494. You multiply by the new matrix. The new matrix is 0.42, 0.40, 0.33, 0.67. So you could open the brackets. You could open the brackets. Yeah. But you must be very careful because matrices, they recognize the order. So next time you put matrices, they recognize order or position. Called commutative law. So to open the bracket, it means everything here is divided by this. So we can divide and confine ourselves to 2 decimals. So 0.42. So this is 2.81. 2.81. Then 0.4 divided by 0.1494 is 2.68. Then 0.33 divided by 0.1494 is 2.21. And 0.67 divided by 0.1494 is 4.48. So that is the universe. Then new final demand, that is our matrix Y. The new final demand, which is our matrix Y. According to the question, we are told the projected consumer demand changes to 400 and 800. So this is 400 and this is 800. That way. Thus, new total output is X is I minus A inverse multiplied by Y. So we already know our inverse is this one, 2.81, 2.68, 2.21, 4.48. We are multiplying by 400 and 800. So remember what we were saying, creating 7, that way. So I will say 2.81 times 400 plus 2.21 times 800. So that is giving me 2892. Then we do the same here. So we can say 2.68 times 400 plus 4.48 times 800, 4656. So that is how you handle that. Is it okay? Yes. Okay. Then finally we can look at another one so that we cement that. There is this one of it's on page 21. Is May 2018. Question 1C.
So this final one is the required gross profit.
Then
The gross output.
yes, the gross output ndio hiyo tumepata. Yes, 2892 and so these two are the answers. For each sector. It's a sector X1, sector X2. So we have said this one is for May 2018. May 2018, question 1C. So that one, it says, a certain firm has three main departments, namely steel, motor vehicles, construction. You can see it, yeah? The three departments are interdependent. Each unit of output from the steel department requires 0.2, 0.3, and 0.4 units from steel, motor vehicles, and construction departments, respectively. Each unit of output from motor vehicles department requires 0.2, 0.4, and 0.2 units from steel, motor vehicles, and construction departments, respectively. A unit of output from the construction department requires 0.3, 0.4, and 0.1 units from steel, motor vehicles, and construction departments, respectively. The final demand for the firm comprises 20 million, 50 million, and 30 million units output from steel, motor vehicles, and construction departments, respectively. So we are told to get the technical coefficients matrix. Technical coefficients matrix. Now, the difference between this question and the other one that we have solved is that the other one, we were given the original values, the totals. So it was upon us, first of all, to add to get the total output, then get the ratios. So here, they already have given us the ratios. And what they are testing is whether we know what is recorded where. And we already have said that in the row, we record the usage of output. And in the column, we record the sources of inputs. So we are going to design our matrix whereby we have matrix A here. And this matrix on this side, we have the producer. The producer, the first sector is called steel. So we have steel. We have vehicles and construction. Then on this side now we have the user. And the user, we have steel, we have vehicle, and we have construction. So that is the design. This is like the one we had yesterday, the transition matrix, that was saying from to. Yes. So this now is producer, user, which is basically the same thing, from to. Yeah. Now, we already have said in the column, we are recording the inputs. In the rows, we are recording the uses. So these values that you have been given, you are required to judge whether it is input or output. And how you judge is, if you look at the second sentence or that sentence, it reads, each unit of output from the steel department requires. So that statement should help you know whether that is about input or output. Tunaambiwa each unit of output from the steel department requires. So is that input or output?
Output.
Eh?
No, requires input.
In input, good. Yeah. So come on input, then you record them in the column.
Yes.
It's as simple as that. So in the column, this will be 0.2, 0.3, and 0.4. Right?
Yes.
The next one is each unit from the motor vehicles also requires. So we record 0.2, 0.4, and 0.2. Then each unit from the construction requires 0.3, 0.4, and 0.1. That's all. You have the technological coefficients matrix. Yes. The next question is the total output of each department, given that the Leontief's inverse matrix is provided below. The total output. Total output. Now, total output is our matrix X. Is our matrix X. And I've told you we have two formulas that we use. There is the formula. There is the formula of A plus Y. A plus Y. Now here A plus Y is used when you have the totals here. But if you have the ratios, we use the other formula, which we have said is I minus A inverse multiplied by Y. That's okay, yeah? Now this one is the one we are calling the Leontief's inverse matrix. The Leontief's inverse. So unlike the other question where we had to look for the inverse, now here they have given us. And that is the reason why I told you not to bother so much on the 3 by 3 matrix. Because the most difficult thing in 3 by 3 matrix is getting the inverse. Because you have to get the minors, the cofactors, the determinant, and the adjuvants. It's a very involving process. So the examiner at this level for CASNEP, they normally provide the answer for that. That's why I told you don't pay a lot of attention to 3 by 3. The only thing that you need to know is how to add them or to multiply. So the examiner has already provided to us, as you can see, the inverse is 1 out of 0.192. Then we have 0.46, 0.43, and 0.30. Then 0.24, 0.60, 0.24, 0.26, 0.41, 0.42. Now this one, we are multiplying by the new matrix Y. Matrix Y, or the final demand, we are told it is 20, 50, and 30. So we know how to multiply matrices. So we just go straight, creating our set that way. So it will be 0.46 times 20 plus 0.24 times 50 plus 0.26 times 30 equals. Now you open the brackets, you divide by this. You divide by 0.192. So I'm getting 151.042. So we multiply this other one, 0.43 times 20 plus 0.6 times 50 plus 0.41 times 30 equals, divide by 0.192. I'm getting 265.104. Then 0.3 times 20 plus 0.24 times 50 plus 0.42 times 30 divided by 0.192 is 159.375. So these are the total outputs from, this one is for the steel, this one is for the vehicle, and this one is for the construction. So that is the answer to Roman 2, the total output.
So,
That's okay, yeah? Okay. So the next thing we are told, the change in total output of the construction department, given that the final demand of steel increases by 2 units, and that of motor vehicles increases by 10, whereas that of construction department does not change. So the new total outputs is going to be x is equals to 1 out of 0.192. So this is 0.46, 0.43, 0.30. Then this is 0.24, 0.60, 0.24, 0.26, 0.41, 0.42. We multiply by the new y. Tunaambiwa that for the steel, it is decreasing by 2. So it is moving from 20 to 18. Then the one of the motor vehicles increases by 10. So it goes to 60. And the one of the construction does not change. So it remains at that. It remains at that. So we just quickly multiply like we have done. That is 0.46 times 18 plus 0.24 times 60 plus 0.26 times 30 equals divided by 0.192. So this is 158.75. 0.43 times 18 plus 0.6 times 60 plus 0.41 times 30 divided by 0.192. I'm getting 291.875. Now 0.3 times 18 plus 0.24 times 60 plus 0.42 times 30 equals, divide by 0.192, 168.75. So the question is change in construction output. So change in constructions output. So it increases by 168.75 minus 159.375. So that is 9.375. See, that is perfect. So with that now, I believe if you came across a question on output input, you should be able to have it. Yeah, perfect. You should be able to have it. So we are through with that area of matrices. So just revise on that. That would be good enough. We proceed. I don't know your time frame exactly what time you have timed yourself up to. Yeah, matrices we are done. Now we need to start something else. We can. I'm not going to. Oh, we stop at that point. Oh, okay.